Okay, threats to systems. As we mentioned before, good old covert channels. There's backdoors, timing attacks, race conditions, buffer overflows, and specific attacks. Does anybody give the definition of a race condition? Or how many people have heard of that before, a race condition? A lot of times you'll hear that within like exploitation or whatnot, to where you have a legitimate resource trying to get to, or a legitimate process trying to get to a legitimate resource. And what you do is you run your application and you try to beat, with your process, the legitimate resource to the legitimate asset or the legitimate item. So basically what you're trying to do is get to there first and either A, prevent the other item from getting it, or B, change it and then leave before the other item actually looks at the file. For example, it might be a race condition on checking to see if a file exists or checking data within a database record. So if you know there's a timing feature to where every 5 minutes it checks to see if a person is logged in at a specific level, you can have technically a race condition to change the record in that database to say they're no longer a guest account, they're admin, and then so forth. But you'll see that a lot with malware and antivirus. So what they'll end up trying to do is they'll look at the antivirus, the process it's running, and they're going to try to destroy the antivirus process or stall it and then alter the signature from the .dat file, the signature file, so the antivirus is still running. It finds all the other malware, but it doesn't find its specific signature. Okay, good old covert channels. Basically, disclose data in an unauthorized manner through covert channel. Channel is a path used for transferring data. Flaws with channels and access controls can lead to covert channels. Overt channel is a medium designed for data transfer. Covert channel is a medium that was not designed for the data transferring, but can be maliciously used in that way. For example, ICMP. ICMP is basically what the systems use for ping packets. And on the OSI model, it's going to be at the same layer as the IP. Because you're going to have your IP, ICMP, and then ARP, and then at the higher level, you're going to have your TCP, UDP. It basically has it to where it's not a communications path. It's an administration protocol. So if you send your ICMP packet from point A to point B, it's supposed to respond with all the data going back to point A, which basically means that you can tell if a system's up or if it's down. Traceroute, by default on Windows, uses ICMP as the protocol to see what hops are going to be on the network. On a Unix box, it's going to be using UDP, but then come back with the ICMP telling it that it's up or how far it's out or what hop or whatnot. Covert timing channels. Basically, this is process relays information to another by modulating the use of the system resources. And covert storage channel. Process writes data to a storage location, another process of lower clearance, and then reads it. Circumventing access controls. Backdoors, these are a fun one. There's the authorized backdoor, or possibly not authorized, but the intentional, which is going to be your maintenance trap or maintenance door. What ends up happening is a lot of people will purposefully put backdoors in an application so they can bypass the access controls to get into the area. Outside software. Good old wireless, another fun one. A lot of times you'll see people to where you have a secured environment where you might have to go through a swipe card, punch in access keys, all that fun stuff, proximity card readers to get into your IT area. Then you'll have a system admin who doesn't like walking up the stairs or going through the security, will put up a rogue access point on the network, and then a lot of times they will encrypt it to secure it, but will only use WPA or whatnot, and then have it to where they can sit out in the parking lot, connect into the network, and then do the configurations. Again, this is not meant for malicious backdoor, but still it can easily be used for various means. Definitely a big issue in security. That's one thing that, from that standpoint, well, you should always do what's called war walking, which is war driving, but you're walking instead of driving. Any sort of site survey with wireless, because a lot of times you'll have people set up, they may not even quote unquote know that the wireless is there. They may just need a specific switch. So they plug in a Linksys, not thinking twice about now it's going to be broadcasting a signal. How many people here have sniffed the airwaves and then found that good old free internet access or free internet Wi-Fi? Almost always going to be an AP. or sorry, not an AP, but an ad hoc network. So it's going to be a peer network. Those are usually backdoors as well. Some sort of malicious software basically took over a system, and now it is being listened to as free internet, hoping somebody will click on it and then connect to it. So a lot of times if you're running a sniffer, you can actually see all of the MAC addresses of computers that are not only potentially infected by something, but all of the computers that have actually double-clicked on the free Wi-Fi, and it's been saved into their Windows XP or Windows 2000 wireless settings. For example, if you go back into here, go into wireless network, anything that says automatic is going to be broadcast. So all you have to do from the traffic perspective is listening to what's going over the wire, and what this system is actually probing for any of those potential backdoors, and will automatically connect. As far as main thing again about a backdoor is you're bypassing security controls, which could either be physical, like with Wi-Fi, or it could be technical or within software, such as if a file exists, or if a specific command is sent to a system, it will all of a sudden turn up or turn on a port number. Maintenance hook is the primary issue with that. From the attacker perspective, a lot of times what they'll do is they'll try to social engineer somebody to install software themselves, so they have local access rights to actually install the items. And the other issue is that if the attacker is able to exploit somewhere, a lot of times they try to go through the maintaining access phase. So the first, if they can, they'll try to do privilege escalation. If they can't, they'll try to maintain access by putting in a backdoor and then try to escalate privileges at a later time. Okay, asynchronous attack. Takes advantage of the time between a sequence of events, basically a time of check, time of use. Basically, attack takes place after the system checks for a specific file and before the system actually uses the file. This again is going to be a race condition, because if you know this is going to happen, it is a timing attack. And you can either A, replace the file before it actually gets used, or do a file lock. And a lot of times what applications will do is if they're trying to write to a file, they check to see if it doesn't exist. If you create it before it actually uses it, it may have some sort of error, but a lot of times it'll actually have some sort of denial of service attack effect if you do file locks. Okay, race condition. Programming issue that could be used in attacks. Race conditions, there's two processes: race to carry out, conflicting actions at the same time. Again, you have your legitimate process, and then you have the attacker's process. Try to get a specific resource. By slowing down one process or speeding up another, an attacker can take advantage of the conditions within the system. Potential security breach, such as a system splits up its identification, authentication, and authorization steps. An attacker uses a race condition that makes an authorization step placed between or before the authorization. And then what ends up happening is now the attacker does not need to be authenticated to carry out a specific task. Okay, data validation. Basically, the criteria of acceptable data. It's a process of reviewing data against a pre-established set of criteria. Security checks on data, along with validation checks, ensure that the data is in proper format. And also there are many examples of these attacks. Most well known is the Unicode. How many people know what the Unicode attack is? Unicode, also previously known as directory transversal before they had to do Unicode. But it's this one right here is the good old .. // So you have your IP address of your target system /scripts, and in IS5 and IS4 especially, that's when the regular directory transversal is an issue. You can run the file from the web server, thinks it's a file, of .. /winnt/system32/cmd.exe, and from the IAS, it thought that the .. was part of the file name. But the operating system sees that as go up a directory. So now what it's doing is it's running cmd.exe from the actual URL. So you send that specific URL, you're doing a dir on the web server, and it usually posts back the information to the web page because the way that it's interacted. This right here, from the attacker perspective, instead of doing dir, they would usually do TFTP. TFTP is a file transfer protocol. It uses UDP port 69. And the fun thing about TFTP is it's installed on every Windows operating system pre-Vista. I think in Vista they took it out by default or disabled it. And then the benefit of that is you can do the TFTP command and then do a -i, then a space the target that you want to have your TFTP server running on, and then basically a get, and then your Trojan or your malware. I usually use netcat when doing a pen test because then you can set up netcat running on a specific port and then connect back to it. So that one line will download your code, and then one other line in the URL. So basically with 2 commands, you not only downloaded the code, you can now run the code with any parameters that you want to pass to it. And with that being said, if you do run netcat, you can now connect to that new port that's now opened up on the system. And the reason why Unicode works is it used to be the ... However, because it doesn't work all the time, people see the ... and then block it out, they specifically put in the %C1, which is another slash, and then also %5C is the other slash. The system will then, it sees that as %5C as opposed to a slash, will then instantly reads it as a slash once it hits on the server side, and then basically translates it. There's another fun one called the dual Unicode, which is they had some interpreters that said, okay, we're looking for the %5C, the %C1, so whenever we see it, we're going to block it, we're going to automatically decode it back to the slash, and then that's what we're doing a blacklist on. Well, since they're blacklisting the specific content, somebody came up with the idea of doing the %255C. The %25 is a percentage sign. So it makes the %25 into a percentage, which is then a 5C, or %5C, and then goes back to the slash. So that's one of the big reasons why with data validation, if at all possible, you do not want to do a blacklist, which is block specific characters. You want to do a whitelist, which is only allow or only trust specific characters. I know with networking that's a little bit harder to do because if you have a web server, you want everybody in the world to be able to get to your web server. But if you have a specific targeted intranet or extranet, then it's real easy to do because only specific nodes you can trust on that extranet. Okay, attacking through applications. You have your buffer overflow. It's probably the most fun one you can possibly go through. Buffer overflow is a continuous segment of memory that holds several instances of the same type of data. An application does not verify the amount of information being inputted, then the data can be overwritten in other memory segments. An attack can cause code to execute in privileged mode, and proper bounds checking is not taking place, which basically means you're not doing input validation. If you specifically went through in basically all your applications and validated the input, the majority or almost all of the vulnerabilities or risk would instantly be taken care of. For example, with buffer overflows, make sure that the source is not going to be larger than the destination and that it's null terminated. And right there you took care of the majority of buffer overflow possibilities. With cross-site scripting, make sure that specific characters are not allowed coming back into it. So basically, if you are only allowing alphanumeric, do not allow the brackets. Just do the A through Z, 0 through 9. Same thing with SQL injection. Same type of content. If you have a phone number, only allow numbers. Don't allow any dashes or anything outside of a 0 through 9, and you should be fine. Again, SQL injection, cross-site scripting, cross-site request forgery. That one, also named the good old cross-site surfing, basically has it to where it's more of a timing attack, really. It still comes back to a cross-site scripting attack, but you're assuming somebody's already logged into another website. Once they're logged into the other website, you're using their authentication and then sending a link. And then if, with any luck, they click on the link, and that could be something, for example, if they're at a bank, that link has specific variables that say, do this action, which is transfer money from this account to this account. And because they're currently logged in, it's instantly going to do that within the application. The problem is the target has to be logged in or authenticated into the system at that given time. Second issue is the attacker has to do a large amount of information gathering on the application the person's going to be using before they can even do it. Your basic cross-site scripting is you just have a specific script that you're going to want them to run. With cross-site request forgery, you're taking advantage of their session. Okay, DOS attacks, denial of service. There's several that you're going to have to memorize, and we're going to cover more in the telecommunications domain. There's a good old SYN flood. How many people know what that is? In TCP/IP, especially for the test, you need to memorize the three-way handshake, which is going to be the SYN goes from the client to the server, or from system A that wants to start talking to system B, sends a SYN packet. That system then responds back with a SYN-ACK. Once the target A sees that SYN-ACK, it then sends a packet saying, yes, I do want to talk. Let's go back to the ACK. Sends an ACK to the other system, then communication starts from there. So it's the three-way handshake which guarantees that the person that wanted to start talking is the individual that is actually talking. With the SYN flood, you're only sending the first packet. And then what ends up happening is you send the SYN to start the communications. The system then sends you a SYN-ACK. You never send the corresponding ACK. So you're sending all these SYN packets, and then the target system is basically starting to fill its queue and not allow anybody else to connect into it. The majority of hardware out there now are networking items. They do protect against that, and almost all IDSs will see a SYN flood when it happens. So it's not really a valid attack anymore. But again, depending on how well the system has been evolved. For example, that directory transversal, almost every web server at one point in its life cycle has been vulnerable to directory transversal attack. So a lot of people say that last time it was an issue was on IIS-5. Well, there's still IIS-5 systems out there, but how many people here use BearShare? Or have ever used a P2P or know what a P2P application is? It's probably a better statement. Okay, people that know what a P2P, BearShare was one of the items kind of like an advanced Napster. So it no longer does just your MP3s anymore. It does all kinds of other items. And it's not centralized because it used the LimeWire, the Notella network. So you have Notella, Gnometella, Nutella, LimeWire, BearShare, and then there's about a dozen other utilities that use the same backend. So every system becomes its own server. And they added the functionality to have it to where there's a web server on every system that's acting as a server. Basically, it allows you to show all the seeded items that you're sharing with everybody else. Well, that was vulnerable to directory transversal as well. So whenever anybody found the port that was open, they were able to read any file that was on the system, basically download it, and basically run anything that was on the system as well. But another thing, for example, if anybody's using, like Apache had a directory transversal problem as well. One of the problems with a lot of the software is that the more people that use it, the more widespread the vulnerability is, because you may have specific pieces of software that are using open source code. They just don't tout it very much. Like a lot of the Soho devices. Small office, home office will be using open source software to keep the cost down, the production environment and whatnot. If, for example, they were using Apache that had some sort of buffer overflow or directory transversal attack to it, they fixed it. A lot of times people do not see that there's been a fix or a patch to their actual device. So their device is from then on going to be known as being vulnerable to an attack. How many people here have used the good old Linksys or the old version? What? The Linksys, was it WRT54G? That has the capability of changing the OS, basically reflashing it to where a lot of attackers were targeting those systems and then had their own operating system that looked identical to the other one from the user perspective, but then it would either put in a backdoor with a proprietary username and password or other functionality in the mix, and then basically upload it to the system and reset it. There's also projects out there, I think it's like openwrt.org, I'll have to check on the website, but they have it to where a lot of people have downloaded some proprietary content, or there was one project where a guy put an asterisk PBX on a Linksys router. How many people know what that is? It's an open source IP, or PBX in Linux. I've also seen a project where Metasploit and Aerodump was put on a Linksys WRT54G. So, but again, back to the SYN flood. If you put in your own OS, there's a good possibility you may be opening yourself up back up for SYN flood. But some of the oldies could still be valid on new technology. Land attack. Basically, destination, source address, port numbers are the same. There is a land attack vulnerability on 2000 and 2003, which basically means that you can use like the HPing2 and then spoof the source port and destination address. You also, or not the destination, but the source port and source IP as being the target's source port and source IP. The system then grabs the packet, doesn't know what to do with it, and it's not really bad TOS. it basically goes to 100% CPU usage and then sits there for, let's say, 5 seconds. But if you were able to send 10,000 packets as a land attack, then you could efficiently take down the system, or at least make it unusable for a period of time. These right here, the types of denial of service attacks, are definitely something you need to memorize for the test. So your good old SYN flood, the land, which is where destination, source address, and port numbers are going to be the same. So as far as the packet's concerned, it came from the target that it's actually going to. Okay, victim system does not know how to process the malformed packet. There's the ping of death. How many people have heard that one before? Good old ping of death was valid basically in Windows 95 A, and then also the older Linux systems. If you sent a ping packet larger than 65,536 bytes, the system would grab it, and depending on the OS, it would either A, automatically reboot, or B, do a blue screen of death. Basically, a vulnerable system may freeze or reboot. Very dangerous system is a protection mechanism or firewall or IDS. The beautiful part about that is if you were targeting a system and you needed it to reboot because, let's say you found a NetBIOS share on it, and then you put something in either the start folder or put something on the disk and then change the registry so it had it to where it's had run services once. If you were able to reboot it, then once it reran, it would run your stuff and then erase itself from the registry and then instantly basically install all the content that you wanted on there. TCP session hijacking basically spoofs the address of one entity in an active connection, injects itself into dialog, may disconnect with the other entity with the DOS. The main reason why you'd want to disconnect them with the DOS is because, especially if you're on the same subnet, you'll get the conflicting IP address issue. So the best thing to do, especially if the target is currently in communications with them, kill them and then instantly try to become them. A lot of times your MAC address, of course, will not match, so that may be an issue, but there's other ways around that as well. Okay, victim is communicating with an attacker and thinking he is communicating with a legitimate entity. An attacker must properly guess the TCP sequence numbers for proper injection. And this right here is going to be extremely hard as well because they have been, each newer operating system randomizes it a little bit better. So the old operating systems, it was relatively easy to guess what the next sequence number is going to be, but the newer ones are actually pretty well randomized. Okay, web spoofing. You can either A, redirect victims to a different site through multiple ways. You can change DNS resource records to point to a different site. There's also putting in a bogus site to capture credit card or data credentials. Web spoofing is fun in different areas. For example, like I mentioned before with the Wi-Fi, you could actually run a program on a Windows box called Enable and do ARP poisoning. So if you know the person that's doing the most interesting traffic, or if they're going to a specific website, you can actually do ARP poisoning, get their traffic to go through you in a man-in-the-middle attack. Then Enable also has the capability of doing DNS ARP poisoning. So whenever they go to the specific website, you can now change their DNS record that they're going to be communicating with, basically. So for example, if they're going to https www.mywhateverbanktheyuse.com, it's now going to you. If you're running something like Peros or Burp Suite, I prefer Peros because just personal preference. You can then have it to where the DNS record is now going to 127.0.0.1, which is localhost, which then instantly goes to your proxy that's running on port 80 or port 443 if it's HTTPS, and then gets rebounced to the real website. So you can make it seamless. So whenever you're doing the ARP poisoning and basically all of the content, they're going to get one packet, or they're going to get one error that says certificate is invalid. Usually what they're going to do is click yes the majority of the time because they want to go to their bank site, or they're getting used to it because of work conditions. So once you do that, you can not only sniff everything, you can change things going to the server before they get there by trapping messages, or change them from the server actually going back to the individual. So as far as web spoofing goes, there's all kinds of interesting things you can do in that space. Then you can also do the DNS poisoning, and then with the web spoofing, you can also, if you have wireless, just change the traffic before it gets to their system. Okay, DNS poisoning. You can poison a DNS server's cache records. This basically is a result that a host name is resolved to an incorrect IP address. And then countermeasures, of course, is DNSSEC. Okay, watching network traffic or sniffing or packet analyzation. There's actually many different terms for it. But traffic analysis is watching traffic and its patterns and try to determine if something special is taking place. A lot of people will use the basic packet sniffing, such as your NetFlow, SFlow data. What that usually does is it grabs the skeleton of the conversation. So it's going to have your port, your protocols, basically a destination source IP, so you can tell who's talking to who at any given time and what they're doing on that line. But if you're doing full-blown packet sniffing, that's going to take a lot more resources, and depending on your jurisdiction, you may have to have special rights and privileges for that as well. For example, like banners, it's a very important thing to do as far as make sure that if you are doing packet sniffing on the environment, the employees know about it, that there's the potential that all conversations can and will be monitored type scenario. Usually it's really easy to do on a phone because it's the sticker, but on a computer system, the banners are pretty useful as well. I read about one case a while back ago that an individual, a kid actually, that basically they hacked their way into an organization. They went into a router and started changing things. The individual was caught. And then his main defense was the banner specifically said, people that are employed with this organization, if you do not have the authorization to be in here, you need to disconnect immediately. His defense was, I wasn't an employee of that organization, so therefore it didn't apply to me. And therefore, he actually got off on a technicality. But again, that's not something I would suggest trying at home. I know a lot of states actually have it now where you have to have express permission to be able to connect to anything. And they're actually trying to push that towards Wi-Fi as well. But on traffic analysis, a lot of traffic has been between two military units, may indicate a military attack is being planned. Increased traffic between human resources and headquarters indicates layoffs around the corner. Eavesdropping on military communications. Hours of the Iraq 1991 bombing, pizza deliveries to the Pentagon increased 100-fold. Basically just means that a lot of people were probably going to be there 24/7 type scenario maybe, or celebrating that they got the go-ahead. With that being said, if you're doing full packet capture, how many people here have used Wireshark or Ethereal? Used to be Ethereal, now it's Wireshark. There's some really cool methods, or basically filters that you can push in there. Basically the good old catch-all is the frame space contains space and then the keyword. And basically anything in any one of the packets with that keyword is going to pop up so you can read it. So it could be your POP3, it could be HTTP traffic. It's really good for the investigation portion. But they actually have some protocols in there that are proprietary protocols. But for example, like MSNIM, which is the Microsoft Instant Messenger. If you type that in there, it's only going to grab the chat traffic going back and forth. So when the person logs in, all the ping traffic saying that they're online, if they change their status from online to idle, it'll be in there. All the communications back and forth will be there. From an investigative standpoint, that's good to look for those specific key terms in the protocol, because it's going to go through, if you have a no chat policy within the organization, that's going to show or prove without a doubt that chat is going through. What email address that it's associated with, and also what IP address it's associated with. And that's another reason why good old plain text versus encrypted. Why you should never use any sort of plain text protocol. For example, POP3. If you're sniffing the network, you will actually see the email come down from the network, or their username and password authenticate with the server, and then the emails start to be downloaded. And then it'll basically say, okay, get 10, get 11, get 12, and you'll see each one of these get commands, and then you can parse each email out. So you can see what they're going to see. Same thing with sending email. If you do not encrypt the email, again, it's going to be in plain text. They're going to see, if you do have to authenticate, the username and password, and then the email that you just wrote go out to the remote email server. Telnet is even funnier, because you actually get to see everything that they see on their screen, because everything that gets represented on theirs is basically line by line type scenario, to where if they do a DIR, you now see the directory listing is the same thing they would see in their command line. So when it comes down to it, that's why you always want to do some sort of encryption. And plain text is definitely not a good idea because of the packet sniffing.